let's put some numbers into this equation. Now, this is a problem that you can solve using kinematics. This is a very simple kinematic equation, a problem that you can solve with kinematics. We're going to solve it using conservation of energy. So yes, it is possible to solve this problem with kinematics. Here I'm going to show you how to solve it with conservation of energy. So what I'm going to do is first I'm going to define two events. My first event will be when it's dropped off the cliff. Why am I choosing that as an event? Because I know the y position of the pebble at that event. I also know the velocity of the pebble because it's dropped. So I know it's going to start off with a velocity of 0 at this event here. And then my final event will be when it hits the ground. Why did I choose that? Because that's the event that I'm being asked about. I'm asking how fast is it going. So I'm asking for v when it hits the ground. So these are going to be my two events. And I can solve now. I'm going to solve for k initial. Because I know that I'm going to use the conservation of energy equation, which says k initial plus u initial equals k final plus u final. So here is my k initial. It's equal to 1/2 mv initial squared. V initial is 0 because we're dropped. So initially my kinetic energy is 0. My potential energy initially is equal to mg times y initial. So y initial is the y position of my object at this event. So the y position of my object at that event is 180 meters. For now, I'm just going to leave this in terms of variables. When I hit the ground, my kinetic energy will be 1/2 mv final squared. And my potential energy when I hit the ground will be mgy final. So I'm going to use my conservation of energy equation here. And I'm going to plug in all the values or the expressions that I have from here. So I'll have 0 plus mgy initial equals 1/2 mv final squared plus 0. The m cancels. And then I can plug in the values. So there's the m's. Those can cancel. I plugged in g. I've plugged in y initial. And the m cancels. And then I can solve for v final. You might be wondering, why is this u final equal to 0? It's because y final is 0. I put my y equals 0 at the ground. So the position of the object when it hits the ground is at a position of y equals 0. So this number here becomes 0, and my potential energy there is 0. Now I can just solve for v final, and I get 59.4 meters per second. Let's do another example. So try this one on your own. I want you to press pause, read through it, and try solving this using that conservation of energy equation. Do not solve this with kinematics. Try using the conservation of energy. And then when you want to go through it with me, press play. So again, I'm going to choose two events. My two events are going to be when it's shot upwards, because I know what's happening then, and when it reaches its maximum height, because that is what I'm being asked about. So I set this up just like my other ones. I'm going to figure out what my initial kinetic energy is and what my initial potential energy is. My potential energy depends on the y position. Well, I'm being shot upwards from the ground, so my initial y position is 0, which means my initial potential energy is 0. When I reach my maximum height, when the object is at the very, very top of its trajectory, the velocity or the speed at that point is 0. So whenever you're at your maximum height, the kinetic energy at that point is also 0. And then my potential energy is going to be equal to m times g times y final. And this y final is the value that they're asking me about. That's what I'm trying to solve for. So now I can use my conservation of energy equation, and I plug in all the values and expressions that I have. Again, you'll see that the m cancels, which is nice. And here I've plugged in my initial speed, and I've plugged in for g. I can cancel out the m, and then I can solve for y final.